Alright, so let's look at this last problem. The directions are the same for 10, 11, and 12, and that's that they want us to find the maximum output of this function and the minimum output of this function, but not only finding these max and mins, but find the location where, for what input does it cause this output, and it wants us to find the input between 0 and 2 pi, including both endpoints. So I've put the basic cosine there just as a reference for you of its 5 primary points and its center line and its max and min. At a quick glance, you can see what that is. So let's quickly determine the max and the min here. The +1 is going to lift that center line up 1 unit, and now be careful with the -4. We're going to have a reflection in this, but the amplitude is 4. So if the new, I'm going to get a blank copy here, and I'll be right back. Alright, so I'm back. I guess I could have just sketched this, but I've got templates, I've got copies of it. The +1, my new center line, this y = 0, has lifted up 1 unit. So if the amplitude is 4, then I'm 4 units above and 4 units below. So my maximum is 4 and my minimum is -4. Now we have to be a little bit careful, because with this -4, we actually have a reflection of this graph about the center line. So I need to treat its max and mins opposite of what I normally have on the basic parent function, the cosine function. Okay, so here with this first at 0 is going to turn out to be a location of a min, and over here at pi is going to turn out to be a location of a max. So I've got 0 here, and I've got pi right here. Alright, so let's jump in and try and figure this out then. So if we know then that if we replaced 3x minus pi over 6 with 0, then if there wasn't a reflection, it would be at its maximum value. But with this reflection, at 0, it would now be a minimum value. So this is going to be the location of a minimum value. Let's solve for x. And I'm getting pi over 18. Alright, I've got these so big so I can see them, but I don't have very much room to write. Now the new period of this 3, take 2 pi and divide it by 3. So instead of multiplying, you're dividing. Instead of stretching, it's a horizontal compression. So we're going to gain extra points of where our max and min occur. Our max and min always occur in the next cycle, 1 period unit away. So if this is pi over 18, then I know that the next time that I'm at a minimum value is, well, if I get a common denominator of 18, the next time that I'm going to be there is at 13 pi over 18. 2 times 6 is 12. 12 plus 1 is 13. And if I add another 12, I'll be at 25 pi over 18. And if I add another 12, I'm at 37. But 37 is bigger than 36. 36 over 18 is 2. They wanted me on 0 to 2 pi, so that one's outside of the interval. So I know that if I plug in these 3 different x values into this function, the output of this function will be at a minimum value of -4 at each of those locations. So now let's come in and find where it's a maximum. So I'm going to erase this and just kind of change color so I want to keep that because, well, I guess you already have it written down that this is your answer for the minimums. Alright, so what about the maximum? Well, normally a minimum is occurring here at pi, but because of this reflection, at pi I've got a maximum. So if I replace this 3x minus pi over 6 with pi, then I know I'm going to, when I plug it in and do this arithmetic, it's going to end up at a maximum value of 4. So let's figure out what x will cause this to be pi by solving this equation. If we add pi over 6 to each side, we'll get 7 pi over 6. And if we divide by 3, we'll get 7 pi over 18. So I've got 7 pi over 18. Now, we know that if we add 12 to that, 12 pi over 18, that if we add 2 pi over 3, we'll be at the next maximum. So the next maximum is going to occur at 19 pi over 18. And if I add, again, 12 to that, 31, and I'm still less than 36 because 18 times 2 is 36, so I'm still on 0 to 2 pi. But when I add another 12 pi over 18, I'm at 43 over 18. 43 is bigger than 36, so I've exceeded that 2 pi. So on this interval from 0 to 2 pi, these numbers are all between 0 and 2 pi, and these three inputs into this function will cause an output of 4, and that's the maximum value that this function ever sees. So when the maximum value is y equals 4 at these three different locations. So hey, I hope that helps, and I'll talk to you later.